Welcome to the class, my dear students. In today's lecture, I am going to explain how to calculate the curl of a vector field. Curl of a vector field V is given by del cross V and is given by dou by dou xi, dou by dou yj, dou by dou zk cross. The function V is given by Vxi, V by j and Vzk. So this we know how to find out the cross product of any two vectors. The same procedure we will be following to calculate the cross product or to find the curl of the vector field. One thing, 2 points here you have to note it down, that the curl is performed on a vector field V and the resultant whatever you got it is again a vector. In the previous case, that means when we calculated the divergent of a vector field, the divergent of a vector field is a scalar, whereas the curl of a vector field is again a vector. And one more important point to understand, note it is, when do you say that the curl of f is equal to 0 whenever, then the function f is called as irrotational. If the divergent of f is equal to 0, then f is called solenoidal and this is called as irrotational. Let us now take this problem to find the curl of the function. Curl V you have to identify as V is given by the function xyi, yzj and plus xz. Okay. So how to find out curl of V is nothing but del cross V and is given by first row. I hope all of you remember how to find out the cross product. In my previous lecture, I have explained how to calculate the cross product of the two vectors. Same procedure it is. Now your del is denoted by dou by dou x, dou by dou y, dou by dou z. And what is f here? X, y, I component, j component is yz, k component is xz. Now we are going to find out the determinant of this. So how to find out the determinant? Take I and take the column now, j second and third columns. So that is dou by dou y and dou by dou z, then yz and then xz, and then minus j times of, now take the first column and the third column, that is dou by dou x, dou by dou z, xy, xz, and then plus k times of your first column and the second column. So that is dou by dou x and dou by dou y, xy and yz. So this is your products. Now how to do this? This is I times of. Now always first what you have to do, this principal diagonal element we will take. So that is dou by dou y of xz minus. Now we are going to take the next one, which is dou by dou z of yz. So that is dou by dou z of yz. So what is the value is this? Dou by dou z of yz is this one and dou by dou z of xz is this one. I hope you are able to understand. So now this is the way to calculate, and then minus j times of, this is this value, okay, and then we will take minus j times of again dou by dou x of xz minus dou by dou z of xy, right? Now plus k times of dou by dou x of yz minus dou by dou y of xy. So this is what you have to get it. So now what is dou by dou x of xz first of all, correct? This is this term. And again you have dou by dou z of xy is this term. So this is what the term. And then you have dou by dou x of yz means this term. Please understand, don't do the mistakes and try to understand and do it properly in the exam. So this is what the values, okay? So now we are going to differentiate this. So what is the derivative? I times of, what is the derivative of xz with respect to y? 0. Yz with respect to z, it is minus y. And then minus j times of, what is the derivative of xz with respect to x? It is z. And what is the derivative of xy with respect to z? That is 0. Plus k times of what is the derivative of yz with respect to x? That is 0. And what is the derivative of xy with respect to y? It is x. So this is what the curl f. So now what is this? It is minus yi, and this is minus zj, and this is minus xk. So this is what you will get as the curl of a vector. I hope you are able to understand how to calculate the curl of a function. So let us do one more problem to find out the curl of a function. Let us say this as the vector field z cosine x is given by z cosine x, z times of cosine x, z cosine x, and then plus sine y I, and then plus x cosine y plus sine z j plus y cosine z plus sine x k. So find the curl of the field, the vector field f. So can you do this? Please wait for the next video to solve this problem. If you are able to get it, fine. It's great thing. Otherwise, wait for the next video lecture. Thank you so much.